Howdy everybody, and welcome back to our Legacy of the Wizard aRPG tutorial. Today we are going to be working on a moving character, so let's get cracking. Now this part of the tutorial is going to cover the most complicated code in the entire game, and I say complicated, this stuff is going to be very complicated. So specifically, let's take a look over here over at our scripts. We are going to be using this, where is it, move with collisions script, and as you can see, this is a huge script containing tons and tons of code with all sorts of collisions and all sorts of interesting things that help keep our player character from falling through the ground, so they can jump on top of monsters, so they can climb up ladders, and it's really complicated and very time consuming. I'd have to make an entire episode just to talk about all the things that are going on in there. But rather than me talking about the things that are going on there, I encourage you to go and watch Sean Spalding's tile collisions tutorials, as they are what I used as a basis for my script for the collision. So I used this one, and then if you feel like going even more advanced, you can go into the slopes, which is, well, like I said, more advanced. But I didn't use slopes in this game, so you don't need to worry about that. Just this one. So anyways, tile collisions need the collision box of your character in order to determine the position that you're at and where they should actually do the collision. And the collision of your character is determined by the character's mask. So in our sprites, we can determine the collision mask, what we want it to be, by using manual, or we just let it stay on automatic. Or we could also create a sprite that we want to use as our hitbox. So that's what I've done. I've made a little collision box, and you come over here to characters, girl, sprite player, and then set that there. Now the character will use that box as their collision box for all the collisions, and that'll be very important. But next up, we have to create a bunch of variables for this new character. Well, actually, first things first, before I forget about it, we also need to create a new object, call it pair_monster, and we'll forget about it for now. We just want it there because the collision script needs to know about the object so that it can actually hit the, so that it doesn't crash. Now, the collision, like I said, it works on tiles, so if you come over into the overworld, you can see where the tiles are by flicking this eye, and that'll show you where the collision tiles are. And you can add in some more tiles if you feel like it for testing purposes by just drawing them in. But you shouldn't need to do anything over there right now. So we just go into our character, and first things first, we have our create event. And we need to set up a bunch of variables for this. Alright, here we go. In the name of keeping our episode short, I am going to copy paste some of this stuff, so ignore the things that I cut out real quick because we don't need them just yet. So we have our image speed equal to 0, animation speed 0.5, direction facing, dur8 dot down, and state is equal to player states dot move. States are how your character determines what in the world it's supposed to be doing at any given moment, and for our case as well, also what sprite it's supposed to be using at any given moment. Direction is, like I said, right, up, left, and so on and so forth. And we'll be determining what these are in a bit as well. Next up, we have our movement variables. So we have our X input, which is 0, Y input, jump input. We have all these inputs here because we are going to be collecting input each frame, as well as this on-ground variable, which is used to determine whether or not we're actually on the ground, so we can jump and whatnot. Then we have our acceleration, and our friction, and our gravity. So you can see I hate using these fractional numbers, but as it turns out, they probably did use fractional numbers like this, and I didn't know it at the time that I was actually doing the right thing, but apparently I was right. Our max speed, so jump speed is -6. That determines how high up we jump. Then our max speed, which is supposed to be our ground walk speed, so how fast can we move left or right. Then our fall speed, how fast we can possibly fall. Then our X speed, which will be capped by these max speeds, and Y speed, again, by the fall speeds. Then we have a selection of other variables. Our B-box side, no one. B-box check. These are used in the tile collisions. And tile map gets the layer name of the collisions tile map so that we can use it in our collisions. Cast magic sound. Well, we aren't casting magic sound yet. And y_fraction is equal to 0. This is used again in our collisions for determining our position. Iframes be used for determining invincibility after you take damage from an enemy. And death stuff done, because, well, if your character dies, we need to know when all the death stuff is done so that then we can move to the death room. But we'll ignore that for the moment. Then, last but not least, we also have this one region here, the sprite lookup table. Sprite lookup table determines what sprite we should be using at any given moment using this two-dimensional array here. So we have sprite states.move dir8.right. So if we are in the move state and we are looking right, then we should be using the player walk right sprite, and so on and so forth. And we'll be using this a lot because we'll have to set up the sprites for every single state, and that'll take a lot of space there. So steps, let's go to the begin step here. We are going to want to capture input. So if we come over here and capture input. There we go. Say our X input is equal to object_input.right check minus object input.left check. This is the same as with the selector and the inventory selector. Just it's select minus the left from the right to determine whether or not we're going left or right and up and down. And then grabbing, of course, our A, B, select, and start. But most important here is our input direction. So we have this value of, say, if we're going right, then this value will be 1. So we have an x2 of 1, y input of 0 or 1 if we are going 1, but in this case we're just going right, so it'll be 1 here, and that will give us a value, point direction, from 0, 0 to 1, 0. And we use that to determine what direction the character is facing. So let me grab that code. There we go. Don't change my facing direction unless I change the direction. So if our X underscore input isn't changing, or if our Y underscore input is changing, then change my direction. So direction facing is the round of the input direction divided by 45. So we have 8 directions. Since we can shoot in 8 directions, that's 45. If we had only 4 directions, we would use 90. And then since 8 is facing right, we set it back to 0 when we get to there. So, alright. that should give us all of our input. Step. So back over here, we set up a state variable over in the animation, player states.move. And we need to use that to determine what in the world we should be doing. So if we throw in this here, what it does is it comes back to here, state underscore state.move, and we know that's equal to 0 because we have our states right here. So event user 0 is what it's executing. Come over here, user event 0, move state, and underscore index is equal to sprite underscore state underscore direction underscore facing. There we go. So that's all we need in the step event. So next up, user move state. And there's a lot of stuff that goes into this as well. I mean, it's almost as complicated as the collision scripts as well. So, you know, it's all terrible, complicated code at this point. But we deal with it what we got. First up, we're going to deal with our animation. So we set our image speed equal to the animation speed, but then we check some cases to see if we should not be animating in certain cases, like if we are facing up. If we are facing up, we don't want to be animating unless we're actually climbing a ladder, but that will be part of the ladder state. So when we're facing up under normal circumstances, don't try to animate us walking up because we are not walking up. And when we're facing down, when we're just walking along, again, don't animate us. We're just looking down. And if our X input is equal to 0, so if we aren't actually doing anything, then set the image speed equal to 0. Now this has a bit of a drawback in that if we come over here to our walk left, you note that we have frame 0 and we have frame 1. So we can actually be in frame 1 and then set our image speed back to 0, and then our character would just be stuck in it in frame 1 or frame 0. It doesn't matter which. So I mean, if we want to say set a specific frame for when we're idle, then we would say image index is equal to 0 or 1 or whatever. However, in the original game, they didn't really do that. But again, it's just a matter of taste, how we feel like setting it up. So next up, we are going to run our calculations for the input. So we go pound regen collisions and movement. And we first off have our X and Y movement. So X movement, if X underscore input underscore does not equal 0, so if we are moving, then set my X speed equal to approach X underscore speed, X underscore speed underscore times sign of X underscore input underscore Excel underscore. So what does this do? What we have here is a sign. Sign gives us the -1 or 1 depending on if our value is positive or negative. So we could have -2,200 and it would give us -1. This is very useful if you have a character that only has a walk right sprite and you want them to be able to walk left using this one sprite. So if the character is moving left, you get the sign, multiply it by the image, scale, and that will flip the sprite over so the character is now walking left. But in this case, we have two different, so we have left and right, so we don't need to bother with that. But we are going to be getting this value to determine which direction we are going. So if we want to be -1 for going left or 1 for going right. So x speed is equal to approach, the x speed variable. So approach is a script that moves the given value towards our target value by the amount. So move my x speed from 0 to 1 if we're going right by acceleration of 1. Alright, sounds good. Else x underscore speed underscore is equal to approach x speed to 0 by friction. Whoops. No, don't want that. Then last but not least, y underscore speed underscore gravity is equal to approach underscore speed. I wish I didn't fat finger so much. By gravity. There we go. And finally, collisions. And again, that's just this huge script that I've created that does all these solid tile detections and determines special cases, like if we're going up, then give us a fall speed, and if we're going down, make sure that we have a platform that we can fall onto, check to see if we're about to hit a ceiling when we jump, all sorts of different things. And I'll have to make a separate episode just on the collisions, so we'll probably do that next. But in the meantime, we're just going to get your character moving. So last but not least, we don't want our character to fall out of the room, so clamp to room. If bbox underscore left is less than 0, then move us back. It's equal to abs bbox underscore left minus x. And if bbox underscore right is greater than room underscore width, x minus equal bbox underscore right minus room underscore width. There we go. So what does that do? There we go. If our character's left bound, so if the left side of the collision box here has gone outside of the room, then move us back so that we are no longer outside of the room. And again, if the right goes outside of the room, move us back so that we are no longer outside of the room. Let's test it out. Let's select our character. No need for an inventory. There we go. We are able to move. And as you can see, we can't move outside of the room. We can look up, we can look down, and we don't animate when we do so. And that's pretty good. So real quick, just before we do anything else, let's go back over here to the step, because we are just going to add a quick special case. So create object cabin underscore door, and just for the we're just going to add in a door here so that we can actually go into the cabin when we want to. So we just made this guy here because we want to have a door object. So if we go back into the overworld resources, make sure we're on the instance, put in the cabin door here. And remember, everything has to be 4 pixels higher than it actually is on here because I messed up with the tile placements. So And we come back to the, not you. Here we go. And we say pound region doors, because we're going to have a couple of these. If we had a much bigger game, we would actually use a door system rather than separate doors, but we only have a couple of doors that are actually needed for the game, so we don't really need to worry about that. End region, and let's add in a cabin entrance. If place meeting, so if at the X and the bottom of the B box bottom, so if the bottom of our hitbox is at our X position, which should be about here in the center, is touching a cabin door, and we press up, then global.previous room is equal to room, global.previous X is equal to 0, global.previous Y is equal to 0, and then we do a fade transition, go to room underscore inside underscore house, and make our state for the input object set to none, and image underscore speed is equal to 0. That way our character can't actually move around or animate during the transition. So let's take a look at that. Again, we can move around, press up, and we are in. Great. That's great. Alright, I think that's everything for this tutorial. So next time I will endeavor to more fully explain how collisions work. So thank you very much for watching, and expect videos to become much longer from now on out. So remember to set the video speed to 1.25 if you find I'm covering topics too slowly for your taste. Anyways, thank you everybody, and good luck with your programming.